Marvell, Anandhi. Hi, all setup done? Cool. Cool. So we have a very tight schedule. So I will say please settle down and let's start with the next presentation. Thanks.
So, hello everyone. It's really fantastic to see the energy surrounding SONiC and that getting increased year on year. I am really thrilled to be part of this event today, and big thanks to Microsoft team for hosting this event for us. I am Anandhi Dhanabalan from Marvell. I am here today to present the contributions of my colleagues at Marvell. So, we all know SONiC's main focus is data centers, but SONiC is definitely rapidly progressing in lot other domains other than data center. In fact, David also iterated this point in his speech. I believe SONiC's modular and scalable architecture along with strong community support is aiding in achieving this. Today I have come to present one such use case from Marvell for SONiC, which is PoE. PoE or Power over Ethernet is basically an enterprise feature and it is used to provide power to endpoint devices. PoE may be a small step for SONiC, but it seamlessly integrates into SONiC's architecture and is definitely a significant step towards establishing a standard NOS as a preferred solution for open networking. So, this is a joint contribution of Marvell and PL Vision. Marvell has been developing PoE based switches for the past 20 years and we have been partnering with major PoE vendors like TI, Microsemi and Analog Devices. Marvell recently contributed to the SAI community by adding PoE attributes. PL Vision has been partnering with Marvell to extend SONiC with PoE functionality. For today's agenda, we will see an introduction to PoE, the various SAI objects added to support PoE, how PoE fits in SONiC architecture and the key takeaways. So, what is PoE? PoE is a method for delivering DC power to Ethernet end devices over copper Ethernet cabling. So, this can be supported only over copper cables. So, in this case we have the switch which is going to be the power sourcing equipment. This is going to power the endpoint devices like the security cameras, wireless access points and VoIP telephones. In the last decade, PoE has been increasing its footprint in enterprise applications. So, why is PoE so important? PoE basically reduces or eliminates the need for power supplies and power outlets, and PoE is being deployed more often due to its ease of installation, efficiency and a wide range of devices are being compatible with PoE. Speaking about standards, PoE is defined by IEEE standards. Historically it is 802.3 AF or PoE which can support up to 15 watts of power, and we have the 802.3 AT which can support close to 30 watts of power, and the latest standard 802.3 BT can support much higher power levels. For SNMP based power management, we have RFC 3621. So, this is an example Marvell platform. Here we discuss the various SAI objects added and how they fit in the physical topology. So, the first object is a PoE device. PoE device basically manages power in the system. So, the power is actually supplied by the PSU, okay, but this power needs to be managed at a global level. So, PoE device handles this task, and when we say power needs to be managed, it refers to how the power is distributed and which PSE receives more or less power and so on. The next object we have is a PSE object. This is the actual chip that is going to supply power. It is in fact capable of managing itself internally, but the PSE chip is unaware of the other PSE chips in the system. So, that is why you need the PoE device to manage all the PSE chips as well. The last object is a PoE port. So, this is where the endpoint devices are going to be connected, and most of the management happens at the PoE port level. Let us check that in detail. So, we will quickly deep dive into the PoE attributes to understand how the object is modeled. So, first for the PoE device, we have power limit mode. Here we support two different modes. The first is a class based mode. In class based mode, the connected device is identified, and based on the device classification, power is going to be limited. So, the initial standards supported up to 4 classes, and the latest standard BT supports up to 8 classes. So, when we say class, it defines the maximum power that can be delivered to the device, okay, and this class based mode would be the default mode as well. The second mode allows to limit the power on a per port basis, meaning you can configure a particular port to deliver a specific power value in watts, like say 5 watts or 10 watts. And then we have a bunch of read only attributes like total power available in the system, the current power consumption of all the devices in all the PoE devices in the system, and the PoE port list, the PSE object list or the hardware in the system, and the hardware version. So, the next object is the PSE. As already stated, PSE is going to be the actual chip that will deliver the power, but that is not going to manage the power. So, all the attributes here will be only read only attributes. So, the first one is the operation status, indicating whether the chip is active or inactive. Next is the temperature. As these chips deliver power, there are chances that they get heated up. So, this attribute helps monitor such situation, and of course, we have the software and hardware version. The last object is a PoE port. So, as I already said, most of the management happens here, and so you can see most of the read write attributes here. So, the admin state allows to enable or disable power supply. The power limit mode allows to specify the power that this port can deliver. Power priority, this is an important attribute. We can classify the ports as high, medium and low priority. Most often systems will not be having sufficient power to support all the PoE ports simultaneously. So, in such cases you can ensure the high priority ports always receive power. For example, you can connect your security cameras to high priority port and ensure they are always operational even during limited power supply. Next is the PoE status. Okay, the PoE standard indicates the standard supported. The PoE status indicates the current power delivery status. PoE detail status provides the reasons in case the port is unable to deliver power. Power consumption displays the current power used by that particular port. Okay, so we all know that a microcontroller is needed for PoE. So, here this slide shows two sample platforms based on how the microcontroller is located. In some platforms, so as shown here, a single chip can handle both the networking and PoE management. So, this kind of integrated PoE mode is what Marvell supports, and other platforms the microcontroller exists as a separate chips external to the ASIC. So, that is shown in the second model. So, the PoE feature integration focus on supporting both this platform types. So, this is realized by using different switch types. So, for the model 1, switch type NPU along with the PoE attributes is used, and for the model 2, switch type PoE along with PoE dedicated SI and a separate PoE SIND controller to manage it is used to realize this. So, let us see how PoE fits in SONiC architecture. A separate Docker container for management is defined. So, this is the PoE manager. The PoE manager functionality includes ensuring the PSE is functional, applying the controller PoE controller configuration, tracking changes to the config DB, and collecting variable data of POE. When I say variable data, it could be the POE status or the PSC information, etc. So that is about the manager. And the SWSS container is also enhanced to support POE. So the changes in the SWSS container basically handle the integrated POE model. And an optional external POE SIND is also defined to handle the microcontroller as an external chip. So this concept is similar to the well-known gearbox model, where you can either have the PHY integrated into the ASIC or as a separate chip based on the ODM's platform design. This feature integration also focuses on integrating the POE component with other SONiC components like the LLDP manager. So LLDP integration is actually optional, but it is preferred to have a proper power up sequence. So I have shared the HLDs for both the SAI and SONiC. So speaking of the key takeaways, this contribution by Marvell and PL Vision extends SONiC to support common deployment scenarios in enterprise networks, and POE is also required by the new PENS subgroup that specifically focused on enterprise use cases. So join us in empowering SONiC to be the preferred solution for open networking. So thank you all. Any questions?
This is Jimston from Celestica. This is just a SAI model, right? Have you done any POC with any specific vendor chips or something like that? Because when I worked in POE, right, some time back, basically any controller, right, supports management modes, something like that, static management mode or dynamic management mode, that kind of thing. But this is something like the basic POE functionality is being implemented in these interfaces. So have you done any POC with?
So as I said, Marvell is working on POE based chips for the past 20 years. So we have our own ASIC supporting this, and this is not only the SAI model, the SONiC feature has also been contributed by partnering with PL Vision. Okay, so yeah, this is a working model. So it's not like a conceptual model, no. This.
Okay. No, what I mean is like, have you done a POC with any external vendor or it's an in-house chip? What are you talking? The controller.
Okay, the integrated model is a in-house POE model, but we have not restricted just to Marvell's use case. We have ensured that all platform vendors model will be covered by also defining the external microcontroller model. So typically it will be most of the vendors, they will have only the ASIC NPU, and they will purchase the POE from vendors like Analog Device, TI, and they will integrate it in their board, like how you have the PHYs, no, external PHY, like that they will do it. So this also covers that model, and for those external microcontroller, we expect the vendors to supply the POE SIND. So that is why it is modeled as a separate thing. If you see in the slide, I am not sure, can the slide be? I think one person there wanted the mic.
Yeah, I think, are you done with your question?
Okay, no, I will just show that. So you see here, right. So this particular version is expected to come from the POE vendor. Based on their firmware, they will have to supply this. So this contribution covers all kind of vendors and use cases.
Thank you.
Yeah. Hi, this is Ramakrishna from Broadcom. This seems to be very basic and very primitive implementation. Actually, I have reviewed this online. Actually, we had our own implementation on the POE. And actually, how do you cater to the various scenarios, like several hardware vendors have the silicon without MCU and with MCU options? Actually, like the interfaces and the communication model will entirely differ, actually, subject to your hardware design. So I saw that several limitations actually when I reviewed the document. So how do you address that? Like, and because I didn't get the clarity, and when I reviewed that, I made a comments on it. So because you can't expect everybody to have an MCU always, because some vendors, some customers do not want to name out, but they go with directly, like, dealing with the PSC chip actually, and then manage the power actually with their own model actually. So here there is a library kind of model actually, like a vendor can, PSC vendor can support us. But the moment you have MCU design, your interface will be in a completely different fashion, and without MCU design, it's a completely different one. So how do you cater to this in your design actually?
So when you say you review the design document, are you referring to the SONiC or the SAI HLD?
This PL Vision and a Marvell document only.
Okay. So now you stated that this is a very primitive model. I would beg to differ, because this handles the most complicated kind of microcontroller models as well. And to talk about the primitive cases like you said, that can, if it is going to be an integrated with just one single PSC, and if you really do not need a PoE device to manage, still you can achieve it by making the PoE device like a virtual object and managing the PSC with this model. Earlier I believe Broadcom had contributed it using like the PMON, okay, using Python scripts, where you directly go and program the PSC. So this is like just a write to register operation.
That's a tightly coupled and implemented.
Yeah.
We only did actually at our
and
side.
that is implemented based on Python scripts.
No, language doesn't matter, but actually like the integration is like our model is based on MCU, but there are several, that's what I'm saying, there are several implementations without MCU as well.
Correct.
The moment you pull this out MCU, when the PSC chip is exposed directly to your silicon, NPS silicon, then interface will change entirely in a different way. So this I couldn't see actually this model fits in that. That's where I am raising this concern.
Yeah, probably we can work offline to see how we can make this model work for that. I believe this can be extended for it. We can work on this offline also if you are interested.
Yeah, so one more question actually. So in a cluster or chassis model of architecture, not necessarily chassis, but in a board you may have multiple power sourcing, power supply units, and you may have multiple MCU and PSC combinations.
Okay.
So how do you dynamically budget your PSC power budget, and how do you allocate those and spread across the power budget to various cards? See here I meant MCU plus PSC is a one unit, another unit may be like the PSC alone. So when you have such kind of units spread across on the one chassis, a tiny chassis, or on the board or pizza box, do you have, I didn't see any mechanism for dynamically computing the power budget and allocating, there is no provision actually. Do you have any comments on that right now?
I do not have the data that you are asking for, but I believe these will be defined by the standards as well. Okay, that is why we have the 802.3
No, this
standards.
is not standard specific. This is like hardware architecture specific actually. So
that could vary depending on the count of PoE ports supported and the PSC ASIC. So it could vary based on the platforms.
yeah, the architecture should support actually. It should allow the provision. It should having the provision to actually accommodate all the cases, right?
Okay, I didn't want to intend to just showcase the Marvell's use case alone. That's why those kind of data is not covered. The point was to see how a contribution is being made to cover all kind of platform vendors. That was the agenda.
So and that too, like the vendor specific PSC vendor specific libraries or whatever actually the code. Do you expect it to be in specific language format or?
No, not necessary. It can be like generic how SIND or anything.
So like, okay, because it's a DB interface, so that DB event goes and
Yes.
the entity, the PMON or like whatever is as POI sync, that should be implemented by the vendor, right? As per your design.
So we expect these drivers to be provided
Completely
by
provided by the vendor, PSC vendor.
The POE vendor, and accordingly they can build their library API and SIND. So this SIND API, everything can be similar to how it is in the current SIND model. So, but still it is up to the vendor. Only thing is they should ensure this interface follows the SONiC nomenclature.
Okay, we can discuss later. Thank you.
Lot. Is there any more question? Okay. If not, thanks a lot for the presentation.
Yeah.